Hi everyone! Today we will be talking about interior angles of polygons. Here's today's FLT. Given properties of interior angles of polygons, I will be able to apply formulas and find missing angle measures. In the previous lesson, we focused on interior angles of triangles. Today, we will take it one step further and look at interior angles of polygons. In the last lesson, we talked about how an interior angle is an angle inside a shape. We know that the interior angles of a triangle sum to 180 degrees. In this diagram, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. We will use this idea to find interior angles of other polygons today. First, let's look at the interior angles of a quadrilateral. Remember that a quadrilateral is a polygon with 4 sides. So here is a quadrilateral, and I am going to see how many triangles I can create by drawing diagonal lines. Notice how if I draw a diagonal right here, I can create 2 triangles. I know that the interior angles of a triangle sum to 180 degrees. In the quadrilateral, I have 2 triangles. So I do 2 times 180 degrees to get 360 degrees. The interior angles of a quadrilateral sum to 360 degrees. What about the interior angles of a pentagon? What will those sum up to? A pentagon is a polygon with 5 sides. Here's a polygon, and let's see how many triangles I can create. So with a pentagon, I can create 3 triangles, and I know that the interior angles of a triangle sum to 180 degrees. Since I have 3 triangles, to find the sum of the interior angles of a pentagon, I'll do 3 times 180 degrees. This equals 540 degrees. So the sum of interior angles of a pentagon is 540 degrees. There's actually a formula to find the sum of interior angles of any kind of polygon. The interior angles of an n-sided polygon sum to the quantity n minus 2 times 180 degrees. Here, n represents the number of sides of the given polygon. Let's use this formula to solve some examples. Here's our first example. What is the sum of interior angles of an octagon? An octagon, as you can see in the diagram, is a polygon with 8 sides. So we will set n equal to 8. Again, because there are 8 sides. The formula is n minus 2 times 180 degrees. We're going to replace n with 8. So we'll have the quantity 8 minus 2 times 180 degrees. Here, notice how n equals 8, so I was able to replace n with 8. Moving on, 8 minus 2 is 6, so 6 times 180 degrees. Feel free to use a calculator here. What is 6 times 180 degrees? It's 1080 degrees. So the sum of interior angles of an octagon is 1080 degrees. Here's our second example. What is the sum of interior angles of a nonagon? First, think about how many sides a nonagon has. A nonagon has 9 sides. So for this example, we set n equal to 9. Our formula to find the sum of interior angles is n minus 2 times 180 degrees. We know that n is 9, so 9 minus 2 times 180 degrees. Here again, we're replacing n with 9. 9 minus 2 is 7, so we have 7 times 180 degrees. And what does that equal? 1260 degrees. So the sum of interior angles of a nonagon is 1260 degrees. Here's example 3. What is the sum of interior angles of a 14-sided polygon? So here we're given that the polygon has 14 sides. So n equals 14. We can find the sum of interior angles by using this formula. And since n equals 14, this becomes 14 minus 2 times 180 degrees. That's 12 times 180 degrees, which is 2160 degrees. So the sum of interior angles of a 14-sided polygon is 2160 degrees. Our last example is a little different. We are asked to find the measure of angle A. Notice here I have a pentagon. It's a polygon with 5 sides. And so let's start off by finding the sum of interior angles of a pentagon. So we're going to set n equal to 5. N equals 5. Let's set up our formula, n minus 2 times 180 degrees. I replace n with 5. And what's 5 minus 2? 3. So I have 3 times 180 degrees, which is equal to 540 degrees. In a pentagon, the interior angles will add up to 540 degrees. So we can use this to find the measure of angle A. I know that the sum of the interior angles will be 540 degrees. It's similar to the examples we did in the last lesson, just with more angles. We don't know the measure of angle A, but I know that the measure of angle B is 119 degrees, the measure of angle C is 92 degrees, and the measure of angle D is 135 degrees. The measure of angle E is 109 degrees. This all sums to 540 degrees. Let's simplify this by adding all of this together. We have the measure of angle A plus 455 degrees equals 540 degrees. To solve for the measure of angle A, let's subtract 455 degrees from both sides. This cancels out, and we solve that the measure of angle A equals 85 degrees, since 540 minus 455 is 85. So the measure of angle A is 85 degrees. For this example, we first found the sum of interior angles of the given polygon. Then, we used that to find the missing angle measure A. Here's a quick review for today's lesson. An interior angle is an angle inside a shape. And the sum of the interior angles of a polygon with n sides is n minus 2 times 180 degrees. Here, n represents the number of sides of the polygon. Great work today, and please remember to submit your notes on Canvas. Thank you.